Hello everybody, I'm Francesco Ambrogi. Yes, I will introduce the first part of this webinar. We are very excited to present the great latest technology related to driving simulator, and specifically talking about HexaRev and HyperDock. And we wanted to show in this webinar how it is possible to bring together the motion simulation with different types of other cues that can be perceived as well on a simulator, like the ones related to NVH. And basically this is going in the direction of supporting early engineering decision that can be taken in nowadays vehicle development challenges. So just to give you a little bit of a context, if we think about how the automotive industry today is challenged, basically we see that there are a lot of challenges that are existing at the same time. On one side, we see that new vehicle architectures are emerging, mainly driven by electrification trends. But at the same time, we also see an increase in the overall complexity of the vehicle and of the systems, where we have more and more interactions between the different subsystems that are present in the vehicle, for sure quite more complex than in the past. Also, new disciplines are, let's say, becoming critical, and in general, software is no longer just a supporting function, but is becoming central to the vehicle behavior. So in this sense, all the electronic controllers are growing, and ADAS functionalities are rapidly becoming a standard content rather than, as in the past, simple add-ons to the vehicle behavior. We are also entering in the era of software-defined vehicles, and here functionalities evolve over time and can be updated over the air, or including AI-driven features. And finally, some disciplines also related to the transition that we are seeing from combustion engines to battery electric vehicles and hybrid vehicles are basically reshaping some expectation and also some development priorities. So as a consequence, we see that, for example, NVH is becoming particularly important for electric vehicles, where the absence of the engine noises is exposing other phenomena, which are becoming, therefore, more and more a challenge to manage. Now, if we think about the driving experience, of course, it is important to recognize that it is not a single attribute that is, let's say, perceived by the driver and by the occupants of the vehicle, but there are a set of concurring aspects that are working at the same time. First of all, for sure, there is the basic interaction between the driver and the vehicle, and this is including the classical attributes such as ride and handling, or also NVH, which are playing a major role in the quality of the vehicle and of the driver. Secondly, we can consider that the interaction between the driver and all the assistance systems, as the before mentioned ADAS and autonomous driving functionalities, are becoming important because they influence the trust, the comfort, and they also in general the perceived safety. And finally, there are also aspects related to the let's say, interaction between the driver and the controls on the vehicle, including all the HMI interface, but also the feel to the inputs like steering, pedal response, and all the digital interfaces. So at this point, all the elements that we have been listing cannot be evaluated in isolation. They need to emerge for the overall driving experience, and basically they do interact in real time. So similarly to what is happening in the real driving experience, we see a similarity in the methodology that can be used in developing the vehicle, and specifically a human-centric approach is which is placing the driver at the center of the development loop is becoming an important aspect to consider. So we must see that there are different cues that must be synchronized and considered, starting from the visual standpoint, which means providing a graphical fidelity on an environment where we want to develop and simulate the vehicle. The same may happen from, let's say, auditory perspective, and also from the vibration perception perspective, as well as from the physical standpoint. We want to have the feeling of accurate motion in the perception of the model. So this aspect is let's say synthesized in what we defined as a human-centric development, where using a driving simulator it becomes possible to unlock several key advantages. So first of all, providing a unified environment is providing a system where engineers can explore the design space in a very broad sense, also including some concepts that may be unconventional or costly or risky to experience at the level of a prototype. As a second point, also the development cycle is shortening because the evaluation of the different solutions may happen, let's say, earlier and also more frequently, so that it can be used to identify and resolve issues before they are propagated downstream. And also from the physical testing point of view, an approach based on simulation and driving simulators is improving the efficiency, because by the time the prototype is built, basically it is coming much closer to the desired target, and so reduce the number of iterations required. And therefore, in practical terms, it is possible to evaluate a wide range of configurations, more subsystems, tire control strategies, and whatever, so that what in a typical testing environment could take a longer time makes basically possible to unlock also dozens of trials and runs in the single day that, as I said, would be not easy or possible in a physical environment. Of course, this approach is also very challenging, because in order to provide the real experience, as we described before, where all the attributes are coming together, it needs a technology that can support that, and specifically all the attributes must be properly synchronized, not just as numerical output, but also as integrated sensations. And this is very important to make decision before accessing to physical prototypes, which is, of course, a situation requiring the increase of the trust in the simulation environment. And we think that in this context, the confidence into the tool is very important. So if the simulation is not accurately representing the reality, let's say the decisions that are taken from there may become riskier, maybe also led to something not completely correct. So for this reason, the approach that we are proposing is the multi-attribute simulation, because in this holistic approach we put all the pieces together and basically reduce the risk of optimizing one attribute at the expenses of another important aspect. So with this, I would leave to Stefano to describe how we implement in our simulator systems.
Thanks, Francesco, for the words. So yeah, as Francesco said, the human-centric and the multi-attribute are the key points that we need to fulfill to have a successful strategy for simulation and for decision making. So what needs to be done is that you need a simulator that is capable of giving the same sensations that you have on the car. And to do that, we need to first understand what you get in the car, and then from then try to reproduce that on the simulator. So in terms of multi-attribute and full spectrum simulator, we know that when driving a car, the occupants of the vehicle are subject to a very wide range of frequencies. And each range of frequency can be, we can group it under different disciplines. Of course, there is an overlap between each range of frequencies, but we can say that the lower part between 0 to 10, 15 Hertz, we are talking about handling, which is sharing some of this range with ride and comfort, which goes, let's say, from 10 to 40 Hertz. And then on top of that, we got the vibration range of frequency, which is going up to 200 Hertz. And then from that point on, still with a little bit of overlap, of course, we have the acoustic region, which is going up to 20 kilohertz. So these range of frequencies can be also are usually addressed by different departments within a company. And if we bring them to, let's say, our simulator ecosystem, we know that we could have the handling and ride and comfort, which is usually covered by our dynamic simulators with the two stage, with the lower and the upper stage, covering from 0 to 40 Hertz. We have our compact NVH that would allow our customers to evaluate vibration, to evaluate the NVH, of course, up until 200 Hertz. And on the same simulator, still with the VI NVH simulator, and of course calibrated headphones or audio system, you could evaluate the acoustic. Now, what we wanted to do was to bring all of these under one single tool. To do that, we kept, of course, our dynamic simulator at the base of everything. We, let's say, replaced, but not completely, the compact NVH with our HyperDock system, which is a cockpit equipped with different shakers placed at the right touch points. We improved we developed and we improved the interface between our dynamic simulators and the VI NVH simulator to create the so-called DMFSS, which stands for Driver in Motion Full Spectrum Simulator. Now, To get to the DIMFSS, of course, we started a journey some years ago. So it was not a process that ended up in 2 months, but it was a some-year journey. We started in 2023 with the launch of the Compact FSS simulator. The Compact FSS is it shared the same carbon fiber chassis with the static compact simulator, and it is the first simulator which is combining the NVH and the handling world. So we are combining the low frequency with the 4 legs installed at the 4 corners of the chassis frame, of the carbon fiber chassis frame. And then on top of that, we equipped the touch points of the driver with shakers. So we added shakers beneath the seat. We added shakers on the steering wheel, and we added shakers under the heel plate. So the main touch points from the driver could replicate also the vibration. As you can see, we have several OEMs and Tier 1 suppliers which already adopted the system. We have 13 systems installed around the world, and one of these is, of course, at our sim center in Udine, in Italy, so available for customer visits and demos. In 2024, instead, we decided to launch the HyperDock. Let's say that after exploring the Compact FSS, we realized the potential that this solution could have. We understood that there was much more we could do. And basically what we were missing was the missing degrees of freedom that the Compact FSS couldn't provide. So for that, we designed the HyperDock, which is a carbon fiber cockpit, which can be used both for handling and NVH evaluation, exactly like the Compact FSS, since it is equipped with the same shakers as the Compact FSS. So again, we have 3 shakers beneath the seat for longitudinal, lateral, and vertical acceleration. We have 4 shakers on the steering wheel for lateral and vertical acceleration, and 2 shakers on the heel plate for, again, lateral and vertical acceleration. At the same time, the HyperDock is also equipped with all the active systems that are usually used on the standard dynamic simulators, like active seat, active belts, active brake. So that allows the customer to drive both in handling and hard handling and evaluate those kind of simulations and NVH. The HyperDock itself then is, as I said, a carbon fiber cockpit, which of course has very much different characteristics compared to the standard cockpits that we usually have on our simulators. First of all, it has a 40% reduction in mass, since compared to a traditional cockpit, we are taking away the top disc, which is the connection plate between the DIM and the cockpit itself. It has 7% less inertia because of how the mass is distributed around the cockpit. It has a 200 millimeters lower center of mass. Again, in this case, removing the top disc helps a lot because we are lowering the overall cockpit on the simulator. And of course, being it a carbon fiber cockpit, we have a structural stiffness which is much higher, bringing also the first natural frequency to a much higher value compared to what we have in the traditional cockpits, which I remember are usually cars which are literally cut and then adapted to be mounted on the simulator. In this case, it's a carbon fiber cockpit completely designed to be run on our simulators. And nevertheless, it's also can be mounted on any existing simulator. So here we have a closer look at exactly how the HyperDock is built. You can see here the shakers that went under the seat. In this case, these are the shakers that are under the heel plate. Then we have these sets of shakers, which instead are on the steering wheel. And finally, the three shakers, which are movers, connected to the steering, the seat rail of the cockpit in the three direction X, Y, and Z. Also, in this case, we have several units around the world. I think that the key aspect of this is that not only we equip brand new simulators with the HyperDock, but that of the names that you see in here, existing customers, some of these were already existing customers which had their own driving simulator from VI grade since several years, and they were able to convert it from a standard DIM to a DIM FSS, a DIM full spectrum simulator, by adopting the HyperDock. And as you can see, we have 8 units, and one of these units is, of course, in our sim center, because updating our DIMs is exactly what we did, as some of our customers has done. We have an HyperDock here in Udine, which is available to be mounted on both our DIM 150 and our DIM 400, and that is used for both R&D activities, of course, but especially for customer demos. Now, finally, we are at the main topic of this webinar, which is our beloved HexaRev. So the last step of our multi-attribute simulation journey was to have something in the middle. We had the compact FSS with 3 degrees of freedom and the vibration at touch points. We had the DIM FSS with the HyperDock, which with 9 degrees of freedom and a large motion envelope. We were missing something in the middle, like a 6 degrees of freedom platform. Here comes the HexaRev, which is again a smaller system, of course cheaper compared to a full DIM FSS. It's quick, it's rigid, and of course it can be equipped with the HyperDock as well for both handling and NVH evaluations. So what about the HexaRev? HexaRev is the VI grade most advanced 6 degrees of freedom motion platform, and its main characteristic is its particular kinematic. In general, for simulators, the main limitation is that each degrees of freedom affect the other. What does it mean? It means that if I move, for example, all the way up with my simulator, then I won't be able to do any yaw because I simply ran out of available actuator travels. HexaRev kinematics has been designed to address exactly this issue. So it is very different from a standard hexapod system, and these allow a much greater motion envelope when doing combined maneuvers. This allows, of course, more natural motion cueing settings, easier motion cueing settings even for the engineer when he has to set up the correct parameters. And this, of course, helps the drivers and engineers in evaluate the vehicle behavior under any condition for each frequency range. So this allows, for example, to run one-to-one maneuvers for ride comfort and NVH evaluations, or to do wide yaw movements combined with lateral and longitudinal when you're doing vehicle dynamics and hard handling simulations. To show what I am talking about, these are some images that shows and clearly shows the motion envelope is compared to a standard hexapod. So in red, you can see the motion envelope in 3 dimensions for the HexaRev compared to the blue motion envelope of a standard hexapod. There are 6 different images. 5 of them are 3D plots. So the first one, as an example, is the capability of the HexaRev of performing Z travel, vertical travel, combined with lateral and longitudinal. And you can see that it is much wider compared to the blue one. This difference is even larger if you move to the center picture, where you have a combined Z travel with a fixed yaw movement of 15 degrees. If on a standard hexapod I do 15 degrees of yaw, basically that's the limit of the simulator. If I'm done that, I don't have any more space to do additional X, Y, or Z. And in fact, you can see that the blue envelope is again much smaller compared to the red one. The same, you can see it on the third picture, where you have yaw and pitch combined, or the yaw and roll combined, and last but not least, the yaw, pitch, roll combined compared between the HexaRev and standard hexapod. The last plot instead is the yaw capability in function of the Z travel, the vertical travel. And also in this case, you can see that in this case, it's just a two-dimensional plot, but you can see that the envelope is again wider compared to a standard hexapod. So, as previously said, the HexaRev is our latest addition in the FSS family, going in the middle between our compact FSS and the DIM FSS. This means that it is born to be equipped with an HyperDock, so that customers will have the complete package to evaluate all kinds of frequency range. A key aspect of the NVH, of course, of the NVH evaluations and the ride and comfort is as well the noise and the quietness of the simulator. It could be that while driving on the simulator, you hear the simulator itself, the noise is coming from the simulator itself. Instead, the mechanical parts that are used to build the HexaRev allows it to be super quiet, so that when you are in the cockpit, you only hear what you need to hear. You are not disturbed by any kind of noise coming from the outside, and that gives you the complete immersion that the driver needs to perform a better evaluation. Together with the motion envelope and its quietness, another key feature of the HexaRev is its versatility. So we already said that all our simulators can be used for any application, but that goes also for the HexaRev. In this case, for example, you can see an example of an open HyperDock cockpit for HMI evaluations, or it can also be used with a Formula carbon fiber cockpit for motorsport. In fact, one of the other characteristics of the HexaRev is fastness and rigidity that allows you to perform even motorsport simulations. So before showing it in action, let's give a quick recap of the main feature of the HexaRev. So thanks to its architecture, the mechanical latency is reduced at minimum. Not only that, but these mechanical characteristics makes it so silent that the driver can feel completely immersed in the simulation environment without hearing anything else from the outside, which is, of course, crucial for NVH analysis. The unique kinematics allows as well for a larger motion envelope when combining multiple degrees of freedom, which is usually one of the biggest limitation in 6 degrees of freedom platform. These allow the engineer to set up a more natural motion cueing for the driver, making it easier for him to evaluate the car. And of course, it makes also easier the life of the engineer who can struggle a little bit less to find the correct parameters for his motion cueing. Its versatility makes it possible to mount different cockpits from the HyperDock to the Formula One for motorsport application. And with the VI0 latency, the response of the simulator is immediate for the best possible realism. So at the moment, we have 2 units existing so far. And again, one of it is the one that we have in our premises, but I'm sure that we'll keep counting. So let's now it's time now to see it in action. So I leave you with the video. So I hope you enjoyed it. I hope you recognize the amazing driver in the simulator. So in this video, it was we covered all the different environments that could be done on the simulator, starting from an urban scenario where we were driving in our laser scanned roads outside our own sim center in Udine, and it was really amazing how we could feel the potholes and these kind of things around the road. It was really impressive, and also the possibility of doing a wider yaw movement than usual when doing all the roundabouts. That was something that was quite important, and it gave a really good feedback. After that, we drove a country road from our virtual proving ground, and also that actually is a laser scan of a road here close to the Udine Sim Center up in the mountains, and also in there it was really nice to feel all the bumps of the road. It was really a nice experience. We moved then to the NVH scenario of our VI grade proving ground. In there, we were with complete one-to-one motion queuing. So I experienced we did the cleats, we did bumps, we did the Belgian blocks with two different lines on the Belgian blocks as well, with different frequency contribution, and then we did also the waves, the long waves. Both parallel waves and let's say unparalleled asymmetric waves, and that was really an incredible experience, because I mean, one-to-one on that with this kind of platform, with its rigidity, it was really nice, and of course also combined with the shakers effect, it was quite impressive. Then last but not least, we did some handling on again on our virtual proving ground, and that was fun. I mean, we tuned the queuing slightly different compared to what we are used here in Udine, also because we are used with a larger motion envelope. So we tuned the queuing a little bit differently with very high gains to make the platform really reactive, and in every correction of the steering you could feel the platform reacting to each correction, together with the VI0 latency, together with the shakers, together with everything. It was an awesome experience. Also, jumping on the curb and then jumping down. It was really, really, really nice. But the good news for you is that you will be able as well to try the HexaRev in one of the scenarios that you saw in the video. The possibility for you to try it is for the 2026 SPS, the Smart Prototype Summit. It will happen in Udine, here in Italy, where also I am based at our sim center, between the 19th and the 22nd of May. This event will focus on how smart prototypes connect simulation, physical testing, measurements, and data intelligence in a single workflow. There will be more than 35 technical presentations and keynotes, more than 20 live demo experiences, 3 dedicated user groups for ride and handling, NVH, and durability and reliability with ENCODE software from HBK. And we expect, of course, a strong audience, international audience of engineers, OEMs, Tier 1 suppliers, partners, research institutions, universities. So it will be an amazing event which should not be missed. Last year, at our 2025 edition, we have more than 300 attendees, so we expect this year to have it even larger event with even more people. So already here in Udine, we started working to prepare all the demos and to prepare the facility as well to welcome everybody here in our premises. You can scan, of course, the QR code that you see in this slide, and that will drive you to the summit website. I also show you these 3 other QR code, which are landing, which will drive you instead to each page from the website of the HexaRev or the HyperDock and of our sim center in Udine. As I said before, in Udine we have all our simulators. We have a DIM 150, we have a compact FSS, we have a compact HMI, we have equipped also with VR, we have the HexaRev, of course, we have the DIM 400, we have the HyperDock, which can be mounted on each one of these simulators, and that's the occasion that you don't want to miss. That's where you should come if you want to try our technology, because we are here available for doing these demos. So I go back also to the SPS so that you can again scan the QR code if you need. And with that, I am done, so I can leave it back to you guys. Or
okay.
Wait for any Q&A.
Yes. Okay. All right. Thank you guys for a great presentation. Now, as you have just mentioned, we do still have time for the Q&A. One last time to the audience, if you would like to ask a question today, you can do so by typing at any time into the Q&A box on the screen. I can see a couple of questions coming in now. If you would like to do so, it's the 2 questions up at the top. So the first one that I have for you guys is about the Udine Sim Center. Someone is asking, how can I test drive and use this simulator that's going to be there? Can the facility be rented for specific customer activities or project needs?
I take one this, or you want to go, Francesco?
Yes, basically the Sim Center Udine is intended to be the place for experiencing all our technology, and specifically, as Stefano pointed out, we have the full setup of simulators available, including the HexaRev and the HyperDock. So this is basically available for tests for customers to experience the technology as a demo experience, but we can also support with our services team specific activity intended to, let's say, perform engineering studies around these technology pieces. So in general, we provide all the engineering support that is required to evaluate specific vehicle features in all the, let's say, domains that we have been talking about today. So from the ride and handling to NVH specifically, we can offer this possibility, and definitely SimCenter in Udine is the right place to be for also setting up a project around this technology.
We've got someone here who is asking, will it be possible to adapt the ergonomy of the cockpit to reflect the reality of the vehicles in production?
I can take this one. So, well, first, hi, Rudy. Yes, I mean, the HyperDock itself, it can be adapted. Of course, we propose a default layout, but as an example, the seat can be exchanged with any production seat, and as well the pedals, positions, and so on. They can be adapted to reflect the ergonomic that you have in your particular car. So even HMI or buttons that can be integrated. Of course, that requires some custom modifications, but that's possible, and that's something that we are actually already doing with customers. So the short answer is yes, it's possible.
We have someone else here who is asking about the total range of motion, translations and rotations, as well as the payload.
So these kind of informations for the HexaRev in particular are available on the website if you register. So if you go on the landing page of the HexaRev here from the QR code, then you can register to the website and then ask for these informations. Let's say that something could be understood by the plots that I showed before with the comparison with the standard hexapod. So in general, there is more yaw compared to a standard hexapod, more pure yaw, and also more longitudinal and lateral travel availability.
Now, I don't know if this question's in relation to your simulator or if it's just asking generally, but someone is asking, would it be possible to simulate marine environment waves?
Well, with the platform itself, the platform could do it, but we are missing the software in that case. So in this particular case, we are talking about just earth vehicles such as cars and trucks.
Okay, cool. We've got a question here. Someone is asking, what frequency range is possible for this full spectrum approach?
So the full spectrum, as shown in the first slide, we are talking about from 0 to 20,000 when we are also considering the acoustics. If we are talking about, let's say, the perceivable tactile vibration, we are talking about from 0 to 150 Hertz, more or less. That's the range where we can have calibrated vibrations, considering, of course, that it's also a handling tool, so that is designed not only for NVH, but for handling and hard handling simulation as well.
This is a fairly long question. Someone is asking, will it be possible to separate the sources of vibrations to include the contribution of subsystems such as the drivetrain in a way that the chassis and the NVH can work on tuning the drivetrain mounts to arrive in compromise for like ride comfort and isolation?
Again, short answer is yes. Basically, that all depends on how you tied the vehicle model with the NVH simulator. So in our full spectrum approach, there are different possibilities. It could be that you have a car real-time vehicle model. The standard, let's say it like this. The standard way that we are proposing with our demos and our standard solution is that car real-time is populating hub accelerations. These hub accelerations are sent to the VI and VH simulator, which is calculating through transfer functions the accelerations at each touch point, being it the seat rail, the heel plate, or the steering wheel. But in reality, this is completely tunable, meaning that if you have additional transfer functions, or if you have additional, you can define additional inputs to the VI and VH simulator. And as an example, if your model has the mounts, the flexible engine and the flexible mounts, you can even use those forces to populate, to be sent to the VI and VH simulator. Then the VI and VH simulator model will need a dedicated transfer function to transform those forces and accelerations to the touch point accelerations. The other possibility is to have directly a multi-body model in the loop. So instead of, which can be both working with in parallel with the VI and VH simulator, or it can be even as a direct actuator of the touch point vibrations. So let's say that you have an Adams real-time vehicle model. Through our VI certified protocol, the Adams real-time vehicle model is already populating the channels that are then used by the shakers to excite the local touch point. So if your vehicle model in the multi-body model has the engine mounts, and of course those are affecting the accelerations at the touch point, then you will be able to evaluate different mounts by running different simulations.
Now we have someone who is asking, can the HexaRev platform be upgraded to incorporate a DIM motion stage in the future?
That's a nice question. Yes, actually the design is started for that. So it's something that it could be in our roadmap. So yeah, in the future.
All right, now we have one more question here. Someone is asking, they say they would like to understand the typical inputs or interface for hands-off of real-time simulation, specifically for the high amplitude motion and the high frequency transfer function models. Is the input the wheel end motion, or reading something in a second language here, something more detailed upstream suspension to maybe body attachment forces? Does that make sense?
Yeah, so this goes more or less with what I was saying before about the overall concept and how the data flow works. It can be in reality anything. So let's say that the lower frequency part, which is the one driven by the simulator itself and not the vibration at touch points, that part is as it has always been for all our simulators. So the simulator and the large movements are driven by chassis acceleration and chassis and velocities. So longitudinal, lateral, and vertical acceleration, and pitch, roll, and EO velocities. For the touch points vibration instead, as I said, there could be there can be multiple approaches. The standard one is to use the hub accelerations and through transfer functions translate these hub accelerations to the local touch points vibration. In this case, of course, let's say that the suspension's stiffness, all the bushings and all of these things are contained within those transfer functions. If someone wants to evaluate different bushings, that would mean that you would need to change transfer function. The other possibility is that the transfer function is not anymore from the hub acceleration to the local touch point, but it could be from the suspension link force to the touch point. And at that point, you have the bushing is in the data which is coming before, let's say. So there could be multiple approaches, and every customer should find, let's say, it's the better solution based on what he needs to evaluate, because that's, of course, the main thing. It all depends on what needs to be evaluated in that particular situation. Another possibility, which I didn't mention before, is that when merging the world of handling and NVH, one thing that really came out was the need of doing replays of simulated data or of measured data. And in that case, with replays, usually the data that are going to each touch point, but also to the platform, are already recorded once. And that is also another clever and a very efficient way of using the full spectrum simulator. So comparing different sets of data, which may come from simulations or from actual measurements. Last year, during our ZPS, so during our summit here at the Sim Center, on our compact FSS, we did exactly that. Customers had the possibility of being on the compact FSS running sets of offline simulations results from Adams to evaluate different stiffness of different bushings of the suspension. And I think that was quite interesting. Also for me, which I am not an NVH guy, it was quite interesting. So.
All right, guys, that is all the questions that we have right now. With that, I would like to bring this webinar to a close. I would like to thank one last time Francesco and Stefano for this fantastic presentation today, and of course to VI-Grade for its role in making today's event possible. Thanks also to our audience for all of your questions and interest in today's event. As always, it's much appreciated. One last time, we will be making an on-demand version of this webinar available as soon as possible. But for now, thank you for tuning in, and goodbye.
Goodbye. Thanks, everyone.